Okay, welcome back. So in this video, I'm just going to review how velocity and displacement are related in terms of a graph, and then walk you through a more complicated example of finding the displacement from a graph. So for some reminders, we use the area under the velocity curve as the displacement of an object. So that area helps us find the total displacement. Then the areas below the horizontal axis represent negative displacement. This means the object is going backward, so to speak, if it's below that horizontal axis, whereas it's moving forward above the horizontal axis. This is just how we choose the graph to work. Then, if the problem is asking you for something to do with distance, just remember that distance doesn't depend on direction. It just wants to know the total amount of distance covered. So you should consider all areas as positive if you are asked to find the distance. That's because we just want to know the total amount that it travels over a period of time, rather than the difference between its starting and ending point. Okay, so let's do an example. Let's consider an object's velocity given by the graph below. So this has a linear portion and then a semicircle portion. So these areas are going to be a little bit different to calculate rather than just rectangles. And let's say the horizontal axis is time in hours, and the vertical axis is the velocity in miles per hour. And again, this is the graph of the velocity. So let's find the displacement from time is 0 to time is 2, and the displacement from time is 2 to time is 8. And I'll just move this time out of the way so that we have some more room to work with. Okay, so for the first displacement from 0 to 2, we're just looking at this little triangle portion. So remember that the area of a triangle is 1/2 times the base times the height. So here the base is 2 and the height is 3. So simplifying that, I'm getting 3 as my solution. And the units here are miles, since we're doing hours times miles per hour. So I'm just going to go ahead and label that section as 3 miles for the area. Okay, next we want to find the displacement from 2 to 8. And we have this half of a circle, or a semicircle. So the area of a half circle is 1/2 pi r squared, since pi r squared is the normal area of a circle, with r as the radius. So here I'm seeing that the radius is 3, so I have 1/2 times pi times 3 squared. So I'm getting 9/2 pi, and it's miles. Just note that we need to then put on a negative here. So this is an area below the horizontal axis, so it's actually negative, and I'm going to label it as negative 9 pi over 2 miles. Okay, so we found two separate displacements. Now let's find the total displacement and the total distance traveled. So to find the total displacement, I'm just going to add up my two areas using the area that is below the horizontal axis as negative. So here I have 3 minus 9 pi over 2 miles. We could convert that to a decimal to get a better sense, but I'm not going to worry about that here. Then for the total distance traveled, we want to consider all of the areas as positive, because we want to know the total amount of mileage covered from beginning to end, not just the difference in where it started to then where it ended up. So here we're going to use 3 plus 9 pi over 2 miles as the total distance traveled. Okay, so that's it for this example. I just want to give you a little prompt to get you thinking about what more we might want to do with this. So here we used a triangle and a semicircle, both of which we had formulas for the area. We've also used rectangular shapes previously, and all of these we know how to find the area of. But what if our velocity curve makes an area that we don't know how to calculate? So here, what if I have a parabola shape? What's the area under this curve? This is something that's going to prompt us to come up with some new techniques for finding area and ultimately develop an integral, which is our way to compute the exact area under the curve. Okay, thanks so much for watching, and I will talk to you in the next one.